Welcome to another GCBASIC video. This video is just actually going to fix a problem. It's nothing to do with floats or anything else I'm working on, but from the left-hand side of my life, we get a post. Okay, and let me take you through the post. Let me just go back. Here we go. Let me just shut that down. Here's a post. It says it's from JB. It was a day ago, and he says he's got a syntax problem with multiple conditions with and or. Okay, so let me have a look at what he's saying. He says he has a program with some syntax, multiple conditions not working. And do you know what? He's quite right. It doesn't work. So he asks the question, will Studio implement this in the future? Well, let's look at the quick look at the program. It's quite interesting. He's using a little tiny AVR chip. And we haven't seen this issue in PIX, but I'll explain that in a bit. Sent some ports to the out. Create some variables and sets a latch, and that latch he's going to use later on. And this is the code. It's dead easy. He said if port B dot 0, and that's an input, is off, and then it turns off an LED and it sets a latch. It sets a latch to 0 and then says port B dot 2 is off. And that's sort of quite important. So that's not where the issue is. And the issue's down here. It says if port B.0 is 1, that means it's high, and the latch is 0, then set an LED to on, that's port B.2, and then set the latch to 1. And why he's doing it is quite clever, because the loop itself means that it never resets this, and it doesn't keep pounding port B.2. Okay, so very clever. He says, if it's off, make sure it's off. So if the switch is off, turn the latch off, and then turn the LED off, and then it says down here, if the port is high, that's live, and the latch is 0, and then it turns it on only once. Okay, so it only does this once. If you didn't have the latch, it would actually just keep turning the LED port B.2 on. It doesn't work. It didn't work. Okay, let's have a look at how I managed to fix it, what I've done to fix this. Okay, here is a great tool. Everyone should have this who's doing AVR. I'll just do an about and do a call out to OSHONSOFT. It's a great piece of software. Oh, let's just do that again because I like the logo. I like the logo. There you go, OSHONSOFT. So I have a license. It's given to me by Vladimir. Why? Because I should use it to debug GCBASIC. And he has his own compiler, but he's really good. Go buy this tool. Okay, reach out, go buy. It's on his website, www.oceansoft.com. It's great simulator, and I'll show you it working. So it's working now because I've fixed the compiler. Okay, all right. So what we've got here on the screen is this is the actual integrated circuit. This is the microcontroller. This is actually the listing that's running. This is the actual program that's running, and that's direct from GCBASIC. Okay. Can I make that a bit smaller? There we go. And these are some registers up here, memory registers, and these are some in the middle here, some other registers. Okay, and so these are the working registers, and up here this is an alternative view of the same registers. So let's just see what I've done back in my source code. Here we go. Here we go. So here is the same piece of code. It's actually in the compiler. I'm actually going to be using a tiny 13 because he doesn't support a tiny 10, but it doesn't really matter because it's still the same issue. It's an AVR. And here we go. I put a no op in here in the program, but it's the same code. And it basically says if port B.0 equals 1 and the latch equals, oh, that should be 0. I was playing around with this. Okay, I'll put it back. Why don't I get his code? I'll get his code from here and paste it directly into here. Then that way we know it's the same code. All right. Great. Compile it up. F6. I'm using build 1377, and that's done a build on that at the bottom here. You can see it's done it at the bottom. Don't really want to spend too much time on that. Back into OSHONSOFT. So stop the compiler. Stop his little tool, and I'm doing that by. And I'll bring that little LED bank in a minute. Let's just tuck that up behind there. Put that on top. And, there's quite a lot to see here, but it doesn't really matter. We've got an LED bank. So what I'm going to do is I'm going to press function key F5 to load my source program. I've already loaded it once, so it knows which file to load. And then I'm going to press function key F2, and it will actually operate. F1, sorry, and it will operate. And now the program is actually running, and it's got different rates, etc. So extremely fast. It's quite nice because you can see what's happening. Now, up here in this red area, I've got the pin B, and that is my input. The DDRB is the input control, and port B is the status of the outputs. So if I push an output, it doesn't really do much in here because I'm under program control. So port B.0 is where he has his input. I push that, and the LED comes on, and that is exactly what he wanted. Port B.2. Turn it off like that. And it's only going in there once because the way he's written his program, which is quite clever. So let's have a look at how that code's working, shall we? Control B brings up a breakpoint manager, but it also brings up the ability to walk the code. So do you want to use the existing listing? Yes, you do, because that's been generated by GCBASIC. Then you can just import that, and it actually brings the code into that little editor. Press function key, change the rate to single step, and we can just walk the code. Press function key F2 now, and I'm walking the code. So look, I'm walking through the code. Now, here we go. This is all the assembler, but I put a no-op. I'll put a no-op in there in the source code so we can find it, but I deleted it by mistake. Here we go. So let me put the no-op back in my source. I'm sorry, just to give you a bit of hope. No-op, function key F6, just recompile things. Reload the code, and then I'm going to run the code. Extremely fast. Control B and load that code up. Great. I've now put a no-op in there. Now if I stop it, we can find that no-op with some ease. So I'm just going to walk it by pushing function key F2. And we can see it's walking through the code, and there is the no-op I've just added. It's on line 1F. And so this is the code. It says here, what's it going to do? This is the new code, so it loads up the value of 255 into a register. And if you want to know how it works, up the top here, in this area where my mouse is, next instructions, it puts 255 into register 21. Well, in GCBASIC, that's called sysvalue copy. And those are all documented inside this source file. So it puts 255 into a particular register, and then it moves that into sysbyte temp x, which is actually register 0. It tests the byte. So it tests the bit. It says skip if the bit is set. Well, it's not set. Oh, actually, I could set it now. There we go. Click. I set it. It says it's left what it did. It jumped over the next line because it is set. Now sysbyte tempx is actually high. It's actually set at R0. If you look at R0 in here on the screen, you can see that R0, the top one, is set to FF. Well, if the bit was low, it would have set it to 0. It now puts that out and moves that out very briefly into systemp1. It then resets sysbyte tempx back to 255 or FF because it could have been 0. And then it tests our little bit that we're going to test, and it's going to actually, this is the test for the latch because it's a bit. It then says, okay, I'll put that in systemp3. So it's tested the bit, and if it was not set, it would have toggled it to 0 by using a complement. It moves that into systemp3. Then it adds systemp3, systemp1 together and moves that into a temporary variable called systemp2. So a lot of stuff going on in the background here, but essentially what it's doing is testing a bit, putting it into one register, testing another bit, putting it into a second register, and in the two together and comparing the result. And these are all system registers, like between the range of R0 and R31. And they're all documented in the ASM. Now it says, if bit 0 of systemp2 is set, jump. And here we go. It jumped across the end if, and now it's going to set the bit high. Bang, it just did it. It did it here. And the LED at the top right-hand corner, left-hand corner, went green. Cycle through. It then goes back to the do loop and comes back round again. There's the no op. It says, the next test is, again, it sets it to 255, these temporary variables. Test the bit 0. Now this time, it is still set, but we've unset the latch. The latch has now been set to 1. And remember, it has to be 0 to turn the LED on, but the LED is already on. So how does it do that? Well, when it gets down here to the AND statement, here, it does the test on systemp2, and systemp2, which is in R2, is already 0. So it says jump to the end. It jumps over setting of the port B.2, and it's away. And that continues on until we unset, pin B.0, which is the input. We'll walk the code and we'll see what happens. Now, because I've just unset it, it's going to take that temporary variable that was always set to high and turn it to 0. Now the AND test is very different, because it now says, well, the latch is 1, but the port is 0. So it turns the LED off. When it exits out from this routine, the top routine he wrote, then turns off the LED and clears it. Brilliant. It's brilliant. The issue that was wrong with the compiler, that it wasn't setting the temporary variables correctly. It was setting them to low. So the AND statement was actually inverted. So you weren't getting what you expected. But this is great, because I've been able to debug this and change the source code to resolve this. And you can see that that fix inside of this OSHONSOFT AVR Simulator IDE. So you don't fly blind. This is a deep dive into this particular tool, but it also shows the fix for this particular problem. So if I run the simulator extremely fast, we can now see it. Every time I turn that LED or that input high, the LED comes on, and we already know that inside of the program it's actually not coming high, and we can prove that, because if we come out, we can prove that. We can just make a small tweak to his program. We'll come out to his program here, and I'm just going to set and toggle up another LED or another output, and I'm just going to toggle port 3, B.3, compile back into the emulator to stop that, reload the code, F5, run the code. Now, when I make the input high, it would not turn on the LED as it was before, but it will also turn on and toggle B.3. So if I go into there and click it, there we go. The 2 LEDs have now come on. But B.3 will only toggle every time I go in. So we know it's not going in there repeatedly because it's not getting toggled at a random pace. We can prove that by coming into here. We can just stop that a moment. We can find where we're setting B.3 high. Where is it? And we walk the code. There it is there. Look. So if I click on that and I run the code again, it never gets there unless we toggle it. So that was a breakpoint I put in this. If I toggle this off, all it's done is turn the LED off, but it didn't hit the setting of port B.3 because it only toggles it once. Click. It's now toggled it once. It's just about to set the LED high. Or it's actually going to invert it. So there we go. It's just inverted port B.3. Great. So we've just adapted this code just to prove things that are happening. So what do we got? A fix. Build 1377. Enjoy.